Good afternoon and welcome, dear friends. Welcome to the CEC live lecture session. In today's session, we are taking up a series that is Big Data Analytics. And in this series today, we will be discussing the topic that would deal with the tool Hive. And to discuss this topic in studios with us, we have Dr. Kashish Ara Shakil. Dr. Shakil is an assistant professor in Department of Computer Science and Engineering, which falls under Jamia Hamdard University. Dear friends, before starting this lecture, let me remind you that if you have any questions regarding this ongoing session, you can call us on our toll-free number, and for that please write down our toll-free number, that is 1-800-110-430. So let's welcome Dr. Shakil to the studios and let's get started with the topic. Welcome to the studios, ma'am.
Hello dear listeners, today we'll be talking about Hive, which is one of the tools which is commercially used by many big organizations, and it can even be used by researchers for carrying out analytics of data which is very large and which we have already studied is called as big data. So now let's have a look at what Hive is. Hive is basically a tool for data warehouse infrastructure to process structured data in Hadoop. So it is a data warehousing tool, and another important point to note about it about this is that it can process only data which is structured, and it works on top of the Hadoop system and is basically used for summarizing, for querying of big data. So there is a layer of Hadoop, and on top of that layer this tool called Hive works, and it can be used for carrying out different kinds of operations such as querying and analyzing in an easy manner. Because why it is easy? Because it is similar to other traditional languages, querying languages which the database users are already aware of, such as SQL. Then firstly, Hive was developed initially by Facebook. Then later on, the Apache Software Foundation, it took up Hive, and then they developed it and it renamed it as Apache Hive, and it is now an open source platform. It is available for anyone to use, and it has a very user friendly interface, and anyone who is familiar with SQL and other querying languages can easily make use of Hive by using something called as Hive query language, which is very similar in syntax to a normal querying language. Hive, as I have already told you, it is now getting used by different researchers, as well as it is also gaining popularity amongst the different organizations, and therefore it has a commercial popularity also. So one of the examples or the use cases we can see of Hive is in case of Amazon Elastic MapReduce, which you are all aware that Amazon Elastic MapReduce, it provides instances to the users in an elastic manner. So Hive, we can say, is it describes it has an SQL like query language called as query, it is called as Hive query language. Then we can say that it is basically used for data warehousing infrastructure, not for OLTP kind of operations. Then it offers tools to enable easy data extraction, transformation and loading. So it offers an easy way in which we can perform different operations like extraction, transactions and loading. Then another feature relating to Hive, we can say, is that it permits the programmers to plug in custom mappers and reducers. So as I have already told you that it works on top of Hadoop. So if you need certain customized mappers and you need certain customized reducer functions, you can it is always permissible for the programmers to use them as plugins. So before moving into further details of Hive, we should understand some of the important points regarding Hive. That is, Hive is not a relational database. It is not designed for OLTP processing, that is, it is not designed for online transaction processing. It is rather designed for OLAP kind of operations. It is a language for real-time queries and for row level updates. So you can make some real-time queries using Hive, but the only difference between Hive and SQL is, in case of Hive, you can make queries on a larger data set. So the processing is faster, and Hive works on top of Hadoop layer. Now let's have a look at some of the features of Hive. Hive, it stores the schema in a database and it processes the data into the HDFS. So the data is stored in form of a database and it is stored in Hadoop distributed file system. We have already discussed HDFS in our previous series. You can have a look at it if you are wondering what HDFS is. Then Hive is specifically designed for OLAP operations. It is not designed for OLTP kind of operations. Hive, it offers SQL type language for querying called as Hive query language or HQL. Then Hive is familiar. Why it is familiar? Because it is similar to traditional languages like SQL. It is fast. Why it is fast? Because it is performing querying on a distributed file system. It offers scalability, that is, it can work on small amount of data, and if you want to exceed the data, it can easily work upon a larger data set as well, and it is extensible. Now, after the features, these are some of the features of Hive in general. Let's have a look at what is the kind of architecture which Hive offers. So firstly, we can see that Hive, it provides the users with a kind of user interface through which the users can access the data, through which they can query the data. So the user interface can be either in form of a web UI, or it can be in form of a Hive command line, or it can be in form of HD Insight. So all this, whenever a query is fired, it is fired via the user interface by any of the three. Then the query, it goes to the meta store, where which keeps on talking with the HiveQL process engine and execution engines, and then they query whatever is the data which is required on the HDFS, and when the query is, when the data is fetched, this information is sent back to the web UI or the user interface where it was actually queried for. So the information is then retrieved and displayed on the user interface. So what is this user interface? Hive, it provides a software for data warehouse infrastructure that can create interaction between the user and the HDFS. The user, it provides an interface that Hive supports. These interfaces can be in form of either a Hive web UI, or it can be in form of command line, or it can be in form of Hive HD Insight, which is generally common in Windows kind of servers. Then let's have a closer look at the metastore. The Hive, it selects the database servers to store the schema or information about the tables, the databases, the columns in the tables, then what are going to be the data types and how the mapping is going to be done. All this information is stored within the metastore. So the metastores can in turn be, we can say they can be three levels. It can be an embedded metastore, it can be a local metastore, or it can be a remote metastore. In case of an embedded metastore, we can see examples are the ones which use Derby. Then we have a local metastore which use MySQL kind of databases. Then we can have remote metastore which queries the MySQL kind of databases using Metastore server, JVM. So these are the three kinds of metastores which could be present in the Hive architecture. Then we within the architecture we had something called as HiveQL process engine. So HiveQL, what HiveQL is that it is a querying language which has been developed for Hive, and it is similar to SQL for performing querying on the schema info which is stored on the schema information which is stored on the metastore. So Hive is one of the substitutes of traditional approaches for MapReduce programming, because if you're using MapReduce for performing querying, then it is a very cumbersome task that you need to understand the entire architecture of MapReduce. You need to understand Java, a high level of Java if you're implementing a MapReduce based program, and it requires a lot of work when you're writing a single MapReduce program. So since Hive, it just works on top of MapReduce, it offers a substitute over this kind of traditional approach. So as an alternative to writing MapReduce program in Java, we can just fire a query which works on top of MapReduce program, and it processes the whatever is the query in a parallel manner using MapReduce kind of program. So if it is performing all these things in a parallel manner, it ultimately performs these operations in a fast manner. So it is faster. Then we had something called as an execution engine as part of the Hive architecture. The execution engine is a combination of HiveQL process engine and the MapReduce. Then the execution engine, it processes the queries and it produces the same result as a MapReduce result. So the only difference is, in a traditional MapReduce approach you have to write the program from scratch, but in case of Hive you can just go ahead, fire some simple queries, and the processing will take place using a MapReduce kind of framework. So as a user, you do not need to understand, and you do not need to have a deep understanding and knowledge of traditional languages like Java. So what you need to understand here is, you just need to understand simple software query language, and using that you can perform any kind of execution. So we can say it uses a kind of flavor of MapReduce. Now let's have a deeper look at the different components in a Hive architecture. Firstly, let's see what is happening at the client side. We said that the client, it will access the processes, it will fire the queries using a web UI, or it can do it through a command line interface, or it can use things like HD Insight, which is present on Windows kind of servers. So but what is happening on the Hive client? Let's see that firstly there's a thrift application. Then this thrift application, it communicates with the Hive thrift client. Then there can be a JDBC application which can communicate with a Hive JDBC driver, and then we can have an ODBC application which will in turn communicate with the Hive ODBC drivers. So the different applications will be communicating with the respective clients or the respective drivers at the Hive client level. Then how the Hive service is working is, at the Hive service level we have the Hive server. This server it communicates with the Hive driver, and then the Hive driver in turn is responsible for communication with the metastore, which we have already seen that this metastore can be of 3 types and is generally used for storing the schema and other related information about the tables and columns which are present in the HDFS. Then the Hive server also has a Hive web interface. Through this Hive web interface, we can communicate with the Hive drivers, the meta stores, and this Hive server. Then we can have the command line interface, which can also communicate with these these drivers, these meta stores, etc. And then we can have other kinds of meta stores, like we can have Apache, Derby database, etc. Then there is a component called as processing and management in case of Hive. Basically this component is responsible for performing the processing. Till now there is a Hive client, it is responsible for communication with the different clients. Then it offers services to the Hive service using a web interface or using a command line interface, and these interfaces, through these interfaces and through these command line, what we can do is we can communicate with the drivers, we can send our queries, then these queries are processed and the corresponding schema is fetched, which is stored in the meta store. But the actual processing and management is being done via a MapReduce kind of application, which is the underlying processing in case of Hive. So we have, it is like the processing and management layer at the bottom, comprising of MapReduce programs. Then we have a Hive service layer, and on top of these Hive service layers we have the Hive client. So then for processing and management we have different tools at the Hadoop level. So basically the processing and management tool is we are talking about is the Hadoop level, where we have tools like Yarn, then we have Tez, and processing taking place through MapReduce. And below this we have the HDFS layer, which is responsible for actually storing of the respective data in the whole architecture or the whole application. So at the bottommost level we have the distributed storage. In this case it is HDFS, that is Hadoop Distributed File System, which is storing the data in a distributed manner. Then we have a processing and management layer which works on top of this data. So this processing and management is the processing part is done by MapReduce kind of functions, and the management is done by applications such as Yarn. Then we have Hive service, which is being provided through different kinds of user interfaces or command line interfaces, and then we have the client level. So this is how the whole architecture of Hive analytics tool look like with 4 layers. Now since we've talked so much about Hive, let's have a look at one of the use cases of Hive in terms of Facebook. So how Facebook, we said that Hive was initially used by Facebook. Now let's see that how Facebook it makes use of Hive. So generally Facebook, it is, as we all know, we are all the users of Facebook. Facebook, it basically comprises of millions and trillions of users, and these users have a lot of data. So managing this data, then querying of this data is a very cumbersome task, because this data is usually very huge and it is very difficult to process it, and even if we are processing it, it will take a lot of time. So one of the challenges with which the people at Facebook face regarding this kind of data is that the number of users is huge, more than 950 millions. Another challenge is that since these users are huge, therefore their data is also huge. That is around 500 TB of data is produced per day by Facebook users. Then another challenge is that the number of queries that are made is that it is around 70,000 queries per day. So whenever you are searching for someone, that is also a query, and Facebook has such a large database. So this search operation itself can be a bottleneck if the techniques are not fast enough. and even the number of photos which we are sharing is also huge. So we have a lot of data which needs to be processed, which needs to be queried for, and of course this data also needs to be stored. So in order to handle such kind of data, what we can do is we can use a technique such as Hive, which works on top of HDFS. So the data storage part is taken care of. That is, since the data is being produced is more than 500 TB per day, so this data storage part is taken care of. Then of course the photos and videos which are being shared are also a part of data, so that will also be taken care of if we are going for Hive. And querying part is also taken care of because it performs querying in a very fast manner and generates faster and more accurate results. So if we do you think traditional systems they can work on such kind of things? If we are not using Hive, then if we go for traditional RDBMS, it will not be able to support such kind of huge numbers, the huge amount of data and the huge growing volumes of users and the number of queries. That is not possible by traditional relational DBMSs. So for that we can go for Hadoop MapReduce, but even Hadoop MapReduce is just for storage, and it will be very cumbersome task to write these kind of programs for Hadoop MapReduce based programs for corresponding to every query, every requirement of ours. So the solution for all this is to go for a technique such as Hive. So Hive, it is a better technique. It provides a more flexible kind of schema, and it provides an evolutionary kind of schema, and it is scalable. So even if today the number of users in Facebook is 950, and even if it goes to say 1,000 millions of users, what we can do is if we are going for a Hive based technique, what we can do is we can just scale it up and then provide the services to the end users. So this is one of the typical use case where Hive can be very beneficial rather than going for traditional RDBMS approaches or going for approaches like Hadoop MapReduce. That is, it performs better querying and generates more optimized results in an easy manner, which is one of the reasons why it has started becoming very popular. And it has a huge number of plugins which are available. Then its JDBC, ODBC drivers are also available, so it is database connectivity is not a problem in Hive. And these tables, we can directly define these tables on top of HDFS. And it supports a large number of formats, scripts, etc. So this is one of the use cases where Hive is very beneficial. So let's have a look at what are the application areas of Hive where you can actually use Hive. So just like I have already said that Hive is an open source Hadoop application based platform for data warehousing, and it provides you with an easy to apply structure to a huge amount of data which is unstructured, and then it helps in performing queries on top of this data using SQL like querying languages. So since it claims that it provides you such ease, such support of huge amount of data, therefore it should have a huge number of applications. So a few of the applications of Hive is that it can be used in log processing, it can be used for performing data mining operations, then it can be used for document indexing, then for predictive modeling, hypothesis testing, then it can also be used in business intelligence and for data analytics, So it has a huge number of applications where we can easily use Hive. In the previous lecture, we had talked about Pig. Pig was a scripting language, and since we already had Pig, why do we need to use a new language, a new query language called Hive if we already have Pig? So there are certain differences in the features of Hive and Pig, and it is this reason that Hive was developed. Firstly was, if you are learning a language like Pig, it is written in Pig Latin, which is a new language, so it is a little difficult to learn. Then Hive, since it is similar to traditional languages like SQL, it is very easy to pick up and learn. Then Pig, it offers schema which is implicit, but Hive, it offers an explicit schema. Hive provides facilities such as partitions, whereas this facility was absent in Pig, and it provides support for servers like thrift server, which was not present in Pig. Then Hive, it enables users to give some kind of user-defined function. This was already present in Pig. Then custom serializer and deserializer was also present in both the languages. So one of the major reasons, if you can have a look at this figure, we can see is that one of the major reason is the similarity and the simplicity which Hive offers instead of Pig, because it is very similar to SQL. Another reason we can say is it provides support for partitions and different servers. So these are some of the reasons why Hive was developed, even though Pig was already existing. Then we can say that these are some of the other features we can see. Out of these features, we can see that both the languages Hive and Pig, they offer all the features like DFS direct access. Then they help in join, order and sort operations they provide. Then streaming is also present in both of them. Both of them provide a web interface, but in case of Hive, it provides support for JDBC, ODBC, which was lacking in case of Pig. And of course there was support for thrift server, which was there in Hive, which was lacking in Pig. Now let's have a look at how the data is being stored in Hive, how the data modeling is being done in Hive. So Hive, basically it comprises of data in form of databases. Database, as we already know, it is a collection of related files. Then it offers different kinds of tables, which is a collection of records. Then it offers partitions, and then it also offers something called as buckets or clusters. So we can see that Hive data model has four major components. That is the database itself. Inside the database we have tables, we have partitions within the tables, and we have buckets and clusters. So now let's have a look at what a partition is. A partition defines it is defined as dividing a table into a coarse-grained part. That is, we are dividing the table into more refined portions, and it depends on the way in which the partitioning is being done, depends upon the partition value, such as the data. So this way, why we are going for partitioning is that it makes the querying faster on the data, on the parts of data rather than the whole data itself. So if we have partitions, it is a faster process. So the partitions can be it might comprise of a key. So the key of partition, it basically determines how the data is actually stored. Then for each partition, the key is unique, and it defines a unique value corresponding to the partition of the table, and these partitions, they are generally named after dates. So why they are named after dates is so that if you want to access these databases later on, or even at the current point of time, it is generally easier to sort out and easy to query. So we'll be discussing more on this in the second half of the lecture. We'll stop here now.
Thank you, ma'am. Dear friends, here we come to the half of this lecture, and we'll be stopping here for a really short break. But before going to break, let me remind you that if you have any questions regarding this ongoing lecture, you can call us on our toll-free number, and that is 1-800-110-430. So stay tuned, we'll be rejoining you after a really short break. Welcome back, friends. Today we are taking a topic that is Hive, and let's get started with this topic. Ma'am, please restart it.
Yeah, we had been talking about what a partition is in case of Hive. We studied that it is basically for dividing a table into a coarser form, that is, we are dividing a table into a more fine-grained level. So whenever we are doing these kind of partitions, we define a unique key for each of the partition. Basically, the partition key, it regulates how the data is going to be stored, and it also these partitions we have talked about that they are stored on the date wise for more convenience, and it is very similar. It is very similar to block splitting in case of HDFS. So let's have a look at what buckets are. Buckets, basically they provide an extra structure to the data that may be used for efficient queries, and it is a join of two tables that are bucketed on the similar columns, including the join. Columns can be they can be implemented like a map side join. So we can use buckets for performing any kind of join operations. Then we can do bucketing by using IDs. So if you are using bucketing, then what it will do help in is it can help in rapidly evaluating a user based query by running it on a randomized sample of total set of the customers. So it would be like, for example, if you have done bucketing on the basis, if you have done bucketing on the data, then we can do this on based on some kind of hash function value of the columns of the table. So let's have a look at how the Hive data model looks like in the lower level. We said that it comprises of partitions, it comprises of buckets. Let's have a look at how it actually looks like. So in case of RDBMS, we have a table with different columns. So this RDBMS is mapped to HDFS. In case of HDFS, we have firstly we have directories, and within these directories we have subdirectories, and within these subdirectories we have files. So we can say is that within the directories, if we have any kind of subdirectories, then these subdirectories are called as partitions, and the files which are stored in these kind of partitions are called as buckets. So we talked about that Hive is a querying language. It is better than Pig, existing languages like Pig. It has a lot of use cases, like in case of Facebook, it uses Hive. But what is the actual advantage of using Hive? Let's have a look at that. It is a higher level query language, and it makes things easier by working with huge amounts of data. So what it means is that Hive can work on data of any size, any volume. Since it works on top of Hadoop, it works on using commodity hardware and is horizontally scalable. So if we increase the data size, then also Hadoop works. Similarly, Hive, which works on top of Hadoop, also works even if the size of the data it grows to a larger volume. Then another advantage of Hive is it has a lower knowledge curve than Pig or MapReduce. Why? Because Hive is very similar to SQL. It is nearer to SQL than other languages like Pig. So if you already know SQL, and mostly people who are studying in computer science, they are usually aware of SQL. Therefore, if you are much more aware of a language, therefore it leads to fewer number of errors, and it is easier to pick up than other languages like Hive, like Pig and MapReduce. Another advantage of Hive is that it works on top of Hadoop. So since it works on top of Hadoop, it also offers all the capabilities, all the features which Hadoop offers. So it is reliable, just like Hadoop is reliable. It is highly available, because even if one portion of the machine it goes down, still the data is backed up, and therefore it ensures high availability. Also, the data is replicated across multiple nodes, which also ensures high availability in Hadoop, leading to high availability in Apache Hive as well. It deals with, has provision for node failure, as well as another advantage is it works on commodity hardware. So if it is working on commodity hardware, it is a cheaper option. It is already using the resources which are already available to the end users. So that is also an advantage of using Hive. Then the database developers, they do not need to study Java programming language for writing MapReduce programs for retrieving data from Hadoop ecosystem. So now they can just fire queries which they were already doing in their database environment. Then it fits the low level interface requirements of Hadoop very easily, very flawlessly, and it also provides support for external tables, which makes it possible to process the data without essentially storing it in HDFS. So we can, when we are working with Hive, we can also work with any kind of external tables as well. Hive also provides a rule-based optimizer for optimizing logical plans. It provides support for data partitioning at levels of tables, and since the data partitioning is taking place at the level of tables, therefore the performance is increasing. The results which are generated are usually faster, because rather than querying on a very large data, at the same time the data is queried on these data partitions, leading to faster generation of results. Then meta store or metadata store is also a very big advantage which Hive, the architecture of Hive offers, because it makes the operations such as lookup operation very easy, faster. So that is also one of the advantages of Hive architecture, that is, it provides faster lookups, easier lookups, better performance, optimized results are produced. It is working on top of commodity hardware, so it has a lot of advantages if you're going for Hive. But there can be certain limitations also of Hive. Firstly is that it is not designed for online transaction processing. So Hive provides support for only OLAP operations, not for OLTP operations. That is one of the limitations of Hive. It does not offer any kind of real-time queries and row level updates. That is not possible if you are going for Hive. Then the latency rate for Hive is usually very high, and it offers an acceptable, not optimal latency for interactive browsing of data. So these are some of the limitations in terms of latency, in terms of not providing support for online transaction processing and for real-time querying, etc. So it is up to you as a user, depending upon your use case. If it fits your use case, you should better go for Hive. Then now let's have a deeper look into Hive and the different commands and scripts of Hive. So if you want to just start off with the Hive, so whenever you will start off with the Hive, what you need to do is you need to enter into the Hive shell. So for that you can use the command HIVE, that is Hive. With this command you will enter the Hive shell. Then if you want to see that all the tables which are working in the Hive database, so once you have entered the shell using Hive command, you can use the command show tables and semicolon, and then you can see whatever are the tables which are currently present in the Hive database. You can also create a database in Hive. For that the command is create database and the name of the database and semicolon. For example, if you want to create a database with the name db_employee, what you can do is, once you have entered the Hive shell using the Hive command, you can write create database and the name of the database. If you have to create a database with a database name db_employee, then you can write create database db_employee and terminate it with a semicolon. If you want to tell Hive to use a database and create tables inside the database, that you can do using the use command. So you can use and the name of the table inside which and the name of the database inside which you want to the database which you want to use, so that you can mention using use and database_name. For example, if you want to create a table inside a database and you want to tell Hive that which database to use for creating table, what you can do is use and for example the database table database name is db_employee, then you can type use db_employee and it will start using the database called db_employee. So we can also create tables in case of Hive. There are two kinds of tables which we can create in Hive. These tables are, one is the managed tables and second is the external tables. Managed tables are the tables which are created in the HDFS, for which we are going to for that the data needs to be loaded separately. So manage tables are within the HDFS, they are embedded within the HDFS, and what we need to do is we just need to load the data. Then another kind of table which is present is called as external table. So what external tables are is that in this case the table is not embedded within the HDFS. We need to link the table to an external file and with the data. So these are external tables. In managed tables, we were loading, these tables were present inside the HDFS, we were loading the database, we were loading the data. In case of external table, the table needs to be, we need an external file to link the data with that kind of table. So let's have a look at how managed tables work. So if we want to create a table, we'll use the create command, create, then table and the name of the table, and then we can give the schema of the table which we are creating. This schema will be comma separated values, and then we can also give the row format which will be delimited by a comma. So if you want to create a table inside the db underscore employee, first what you can do is you can use the use command to tell the Hive that this table, that this database is going to be used and we are going to create tables under this database. So you can say use and the name of the database. Then you can type the create table command. For example, if you are creating a table called tb underscore employee, you can write create table, name of the table, that is tb underscore employee. Then you can mention the schema of this. For example, it can have something called as model, which will be of the kind string. Then the schema, the point to be noted is that these schemas are comma separated values. So if the schema has three kind of values, int, string, string, so we can write, for example, if the first string is called model, so we can write model and the data type, that is string, then comma, name of the next schema value, that is id, and its data type. For example, if it is int, then again another name for the values inside the table, brand, for example, if it is brand, and then the data type for this string. But the only thing which needs to be noted here is that these values are comma separated. So it's just very similar to SQL. There also, when we are creating a schema or a table, we need to mention the data type of the attributes. There the columns are called as attributes in case of RDBMS. So the name of the attribute or the column and its type, very similar to a normal RDBMS schema. If you want to create an external, that was the case of managed table, we just need to mention the word table. But if we want to create external tables, then what we can do is we can use the command create and write the word external table and the name of the table, and then we can give whatever are the values of the columns or the attributes. These values will be comma separated, and then you can, since we said that external tables, they have a link to the actual data, which is where the actual place where the data is stored, or the link to the file or the path is there. So this location will also be present when we are creating an external table. That is, we need to mention that at what location we can load data from, and which file has the data from which location in case of external tables. For example, if we are taking the we are going to create a table called as tb underscore emp underscore ext. So here also, again, if you are going to use certain database, then you would use the command use and the name of the database, then you will create a table inside this. So if it is an external table, you will use create, then you will explicitly mention the word external, then table, name of the table. For example, if it is tb underscore emp underscore ext, then this name will be there. Then we'll be just defining the different attributes. So it will be if it is model, then model, and then data type. If there's an attribute called ID and the data type. If there's an attribute called brand, then brand and its data type. So in this case, the data types are string, int and string respectively. So those data types will come. Then we will mention the location of the file on the HDFS. So that path also we need to give. And in this manner, we can create an external table. So there are certain things which need to be noted is that data is linked to the table while creating the table in case of external tables, but in case of internal tables you just load the data explicitly, therefore you do not need to give the location. Therefore, if you have to the data file in a local file system, you will need to copy the file from the local file system to HDFS. How you can do this? You can use HDFS commands like copy from local or put, that you can do. So when you are giving the link to a table, what needs to be done is that the link to the file which you are giving, that file should be present in HDFS. So if your any of the file which you need to use, which you need to link, if it is not present in HDFS, it is present on the local file system, what you need to do is you need to import it into HDFS. That can be done using copy from local or put command. And in case of manage tables, the data needs to be loaded after the table is created. So in case of external tables, we need to give the links at the time of creation of the table. In case of manage table, we will load the data after the table has been created. And another point is that we need to mention the path of the file. So this is these are the two kinds of tables which are explicitly present in Hive: manage tables and external tables. Now we have the data. Now we are aware that what a managed table is, what an external table is, how do we create a managed table, how we create an external table. Let's have a look at how we are going to add this data to the managed tables, how we are going to load this data. So if you want to load this data, again you need to be present in the Hive shell itself. So you will inside the Hive shell, you will go to the Hive shell using the Hive command. Then you will give the command load data local in path of the local file where the data is present into table, then the name of the table where into which the data needs to be loaded. Then if you want to run these queries, so this is how you have just added the data to Hive table by using the load command. Load and giving the path of the file on the local file system and mentioning the name of the table into which you want to load this data. So now the data is loaded. Now you can perform querying operations. So you have now created a managed table, you have created you know how to create an external table, and you also know how to load data into these higher managed tables. But now if your data is present, what you can do is you need to perform some kind of query operations on top of this data. So for if you want to select all the rows, if you want to display all the information of the table, what you can do is you can write the word select star from and the name of the table. For example, if you want to fetch all the information from a table called as tb underscore emp, what you can do is you can write select star from tb underscore emp. It will display all the records which are present within this table called as tb underscore emp. So you can see that this query, this small query operation or this small query which we have written in Hive is almost similar to the one which we do in SQL. In SQL also, if you want to fetch the entire details, all the entries of the table, what you can do is you can just write select star from and the name of the table. So here also it is same. The only difference is now you are in the Hive shell and you are working on top of HDFS or Hadoop. If you want to see that where the database folder, the table folder and data files are created, you can use some of the Hadoop commands. These commands are also very similar to the normal shell scripting commands. You can write Hadoop fs -ls and then you can write user Hive warehouse, and that is you just give the path of the Hive, and then you can see that where your database folder, table folders and your files are created through the Hadoop fs -ls command, -ls command. Just like SQL, here also you can delete a table. The syntax or the query syntax is very similar to SQL. You just need to be in the Hive shell. You can get into the Hive shell by using Hive command, HIVE. You'll get inside the Hive shell. Then you can write just simply drop table and the name of the table which you want to delete. So this leads to the deletion of the table which is stored in Hive. If you want to delete an entire database, that also you can do. Drop database and the name of the database. So here also we can see that the syntax is very similar to a normal SQL language. One thing which we need to note here is that if we are deleting a database, it is also, I think it is there in SQL also, that if we are deleting a database, we need to delete all the entries, all the tables corresponding to the database which are present within the database. So for that, if you want to perform a drop command on a database, what you need to do is you need to drop all the tables first. So if a database, say DB_EMP has two tables, TB_EMP and say student_EMP, what you can do is first you need to perform drop on the first table, that is drop TB_EMP, then drop on the student table also, drop table student_EMP. This will drop all the tables. So now we have no table left in the database and we can just go ahead and type the drop command for deleting the database. So we can just write drop and the name of the database and we can delete the entire database itself. So this is how you delete a database. We have learned how we'll enter into Hive shell by using the Hive command. We can also exit the Hive shell by using the quit command of Hive. So you just need to type quit and semicolon and you will come out of the Hive shell. So with this we will come to the end of today's lecture on Hive. These are some of the references which we on the basis of which we have given today's lecture. We'll be discussing more on these big data analytics tools in the upcoming lecture. I hope it would have been a good learning experience to all of you. Thank you so much.
Thank you, ma'am. Indeed, it was a really informational lecture. And dear friends, I'm sure that you must have gained knowledge from today's lecture. We at CEC are always ready with such educational and informational lectures for you. So stay watching us and stay tuned. Thank you, ma'am. Thanks once again.